Hello viewers, welcome to my channel Maths with VTC. Today we are going to see problems in exercise 5.1, which is in the chapter Arithmetic Progressions. All the problems will be very simple. You can easily solve the sum. The first problem. In which of the following situations does the list of numbers involved make an arithmetic progression and why? The first situation. The taxi fare after each kilometer when the fare is rupees 15 for the first kilometer and rupees 18 for each additional kilometer. In real life, we might have come across this kind of situation. So let us see. The taxi fare for the first kilometer is 15. For the second kilometer, 15 plus 8. Third kilometer, 15 plus 16. Fourth kilometer, 15 plus 24 and so on. Therefore, the sequence of numbers is 15, 23, 31, 39 and so on. Clearly, it is an arithmetic progression with the first term A is equal to 15 and the common difference D is equal to 8 because each term is obtained by adding 8 with its previous term. Therefore, it is an arithmetic progression. Second sum. The amount of air present in a cylinder when a vacuum pump removes 1/4 of its air remaining in the cylinder at a time. So each time the vacuum pump removes 1/4 of the air in the cylinder. So after removal of 1/4, what will be the air in the cylinder? It will be 3/4. So now let us see the solution. Let the amount of air in the cylinder be V. Every time 1/4 of the air is removed. Therefore, each time the amount of air in the cylinder will be V 3/4 into V, 3/4 whole square into V, 3/4 whole cube into V and so on. Clearly, A2 minus A1 is not equal to A3 minus A2. You can give certain values for V and you can verify this. Therefore, this is no longer an arithmetic progression. The cost of digging a well after every meter of digging when it costs rupees 150 for the first meter and rises by rupees 50 for each subsequent meter. A similar problem already we discussed. So the cost of digging a well for the first meter is rupees 150. For each subsequent meters, the costs are rupees 150 plus 50, 150 plus 100, 150 plus 150, etc. That is, the sequence of numbers are 150, 200, 250, 300 and so on. So clearly it is an arithmetic progression with the first term 150 and the common difference 50. It is very clear. Now fourth problem. The amount of money in the account every year when rupees 10,000 is deposited at a compound interest at 8% per annum. So it is compound interest. Every year interest is added to the principal. So first year it is 10,000 rupees. Second year the interest is added to the principal. Third year again the interest is added to the principal and so on. So first year the money in the account is rupees 10,000. Second year the money in the account is rupees 10,000 plus interest. Interest is rupees 800. Therefore it is 10,800. Third year, the money in the account is 10,800 plus the interest earned by 10,800 at the rate of 8%. Therefore, it is 11,664. Clearly, A2 minus A1 is not equal to A3 minus A2. Therefore, this is no longer an arithmetic progression. Second problem. Write the first four terms of arithmetic progression when the first term A and the common difference D are given as follows. So when A is given and D is also given, you can easily write the arithmetic progression because the first four terms are A plus D, A plus 2D and A plus 3D. So it is very simple. So first problem, A is equal to 10, D is equal to 10. Therefore, the solution is 10, 10 plus 10, 10 plus 20, 10 plus 30. That is 10, 20, 30, 40. These are the first four terms of the required arithmetic progression. Second problem. First term is minus 2. Common difference is 0. Therefore, minus 2 plus 0, minus 2 plus 0, minus 2 plus 0, all the terms will be minus 2 only. So it is also an arithmetic progression. Third problem, A is equal to 4, D is equal to minus 3. Therefore, the four terms are 4, 4 minus 3, 4 minus 6, 4 minus 9. That is 4, 1, minus 2, minus 5. These are the first four terms of the required arithmetic progression. Fourth problem, A is equal to minus 1, D is equal to half. Therefore, the first four terms are minus 1, minus 1 plus 1 by 2, minus 1 plus 2 by 2, minus 1 plus 3 by 2. So when you simplify, you get minus 1, minus 1 by 2, 0, 1 by 2. So these are the first four terms of the required arithmetic progression. Fifth problem, A is equal to minus 1.25 and D is equal to minus 0.25. The first four terms of the arithmetic progression are minus 1.25, minus 1.25, minus 0.25, because here D is negative. Therefore, it is minus 0.25. Next to minus 1.25, minus 0.5, minus 1.25, minus 0.75. That is minus 1.25, minus 1.5, minus 1.75, minus 2. So these are the first four terms of the arithmetic progression. Third problem, for the following arithmetic progressions, write the first term under the common difference. It is very simple. Just by seeing the arithmetic progression, you can answer it. First problem, 3, 1, minus 1, minus 3, and so on. Therefore, the first term is obviously 3. To find the common difference, we find A2 minus A1 and A3 minus A2. Here it is 1 minus 3, which is equal to minus 1 minus 1, which is equal to minus 2. Therefore, the common difference is minus 2 for the first arithmetic progression. Now we move on to the second problem. It is minus 5, minus 1, 3, 7, and so on. Therefore, A is equal to minus 5. What is the common difference? You find A2 minus A1 and A3 minus A2. Clearly, it is equal to 4. Therefore, for the given arithmetic progression, A is equal to minus 5 and D is equal to 4. Third problem, 1 by 3, 5 by 3, 9 by 3, 13 by 3, and so on. So here also the first term is simple. It is A equal to 1 by 3. To find the common difference, you find A2 minus A1 and A3 minus A2. So clearly it is equal to 4 by 3. So common difference is 4 by 3 for the third arithmetic progression. Fourth one, obviously A is equal to 0.6. To find the common difference, you find A2 minus A1 and A3 minus A2, and they are equal to 1.1. Therefore, common difference D is 1.1. Fourth problem, which of the following are arithmetic progressions? If they form an arithmetic progression, find the common difference D and write 3 more terms. So, in all the problems, we have to find the common difference D. So, to find the common difference, we check whether A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A3, etc. If all the inequalities hold good, then common difference exists. Otherwise, there is no common difference and the given sequence is not an arithmetic progression. That should be your conclusion. Let us look at the first problem. 4 minus 2 is equal to 2. That is A2 minus A1 is equal to 2. Whereas A3 minus A2 is equal to 8 minus 4, which is equal to 4. Therefore, this is not an arithmetic progression. Now we move on to the second problem. 5 by 2 minus 2 is equal to 1 by 2. 3 minus 5 by 2 is also equal to 1 by 2. 7 by 2 minus 3 is also equal to 1 by 2. Therefore, clearly, common difference is equal to 1 by 2. Therefore, this is an arithmetic progression. Now, we have to write 3 more terms. So, to write 3 more terms, you add 1 by 2 to the last term, and then 1 to the last term, and then 1.5 to the last term. So, when you add 1 by 2 to 7 by 2, you get 8 by 2, which is equal to 4. Again, you add 1 by 2, you get 9 by 2. Again, you add 1 by 2, you get 5. So, the next 3 terms of the AP are 4, 9 by 2, 5. Third problem, minus 1.2, minus 3.2, minus 5.2, minus 7.2, and so on. So what is the common difference? A2 minus A1, which is equal to minus 2. A3 minus A2, which is also equal to minus 2. A4 minus A3, which is also equal to minus 2. Now you can write the next three terms of the arithmetic progression just by adding minus 2 to the last term. So the next three terms are minus 9.2, minus 11.2, and minus 13.2. Fourth problem. What is the common difference? A2 minus A1 is equal to minus 6 minus minus 10, which is equal to 4. A3 minus A2 is equal to minus 2 minus minus 6, which is also equal to 4. Similarly, A4 minus A3, which is also equal to minus 4. Therefore, this is an arithmetic progression with a common difference 4. Now you can write the next three terms, and they are 6, 10, 14, because we are given last term as 2. Therefore, 2 plus 4 is equal to 6, 6 plus 4 is equal to 10, 10 plus 4 is equal to 14. Fifth problem, 3 plus root 2, 3 plus 2 root 2, 3 plus 3 root 2, and so on. Let us find the common difference. A2 minus A1 is equal to root 2, A3 minus A2 is also equal to root 2, and A4 minus A3 is also equal to root 2. Therefore, the common difference D is equal to root 2. Now you can write the next three terms of the arithmetic progression by adding root 2 to the last term. So the next three terms are 3 plus 4 root 2, 3 plus 5 root 2, 3 plus 6 root 2. Sixth problem. 0.2, 0.22, 0.222, 0.222, and so on. Obviously, A2 minus A1 is not equal to A3 minus A2. Therefore, this is not an arithmetic progression. Just by inspection, you can say the answer, but you have to give proof like this. You find A2 minus A1 and A3 minus A2. If they are unequal, immediately you can conclude that it is not an arithmetic progression. Seventh problem, 0, minus 4, minus 8, minus 12. So obviously the common difference is minus 4. A2 minus A1 is equal to minus 4, A3 minus A2 is minus 4, and A4 minus A3 is also minus 4. Therefore, it is an arithmetic progression. Now you can write the next three terms, and they are minus 16, minus 20, minus 24. Eighth problem. Minus of, minus of, minus of, minus of. All the terms are minus 1 by 2 only. Therefore, you can easily guess that the common difference is 0. Therefore, the next three terms also will be minus 1 by 2, minus 1 by 2, minus 1 by 2. Therefore, this is an arithmetic progression with the common difference is 0. Ninth problem. 1, 3, 9, 27, and so on. So when you find common difference, A2 minus A1 gives you 2, whereas A3 minus A2 gives you 6. Therefore, it is no longer an arithmetic progression. 10th problem, A, 2A, 3A, 4A, etc. So when you find A2 minus A1, you get A. A3 minus A2 is also A. Therefore, the common difference of this arithmetic progression is A. Therefore, now you can write the next three terms. After 4A, you will get 5A, and then 6A, and then 7A, because the common difference is A only. 11th problem. A square, A cube, A power 4, etc. So when you find A2 minus A1, you get A square minus A. A3 minus A2 is A cube minus A square. Obviously, both are not equal. You can give some value for A and you can verify this. Therefore, common difference does not exist. Therefore, this is not an arithmetic progression. Similarly, 12th problem. Common difference does not exist because A2 minus A1 is not equal to A3 minus A2. Therefore, it is not an arithmetic progression. Similarly, 13th problem. Root 3, root 6, root 9, root 12. When you find a2 minus a1, you get root 6 minus root 3, which is not equal to a3 minus a2, which is root 9 minus root 6. Therefore, this is also not an arithmetic progression. 14th problem. 1 square, 3 square, 5 square, 7 square, etc. Clearly, it is not an arithmetic progression because the common difference does not exist. It is 3 square minus 1 square and 5 square minus 3 square, both are unequal. Therefore, common difference does not exist. Therefore, it is not an arithmetic progression. 15th problem also not an arithmetic progression. Thank you viewers for watching my video. Don't forget to subscribe this channel. You also share this video to your friends too. Thank you.